Okay, so when we have a B plus tree and we plan to do some queries, and the query process actually matches the searching process in the index tables. Remember before we mentioned we have different queries, right? Either equivalent query or some range queries. Now here we provide you with the example. We want to select name, this attribute, from people, this table, where age equals to 25. And here let's assume we have an index table created for this age as such key. If we have some queries like this, and how can we do the search process to find records matching this condition? Normally you can imagine, right? We start from the root and we proceed down, matching the key values versus this provided value, right? Decide which branch to go to until we reach the leaf. And in the leaf, we still find if we can find some tuples matching this record, right, with 25 as age, and then we can access the concrete tuples and return the name attribute of a tuple. This is the equality queries, right? The search process in the index tree. And the query for some range queries, it will be very different. Now here we have an example. We select name from people where age is no greater than 20, where the age is no smaller than 20 and no greater than 30, in the range from 20 to 30. And how can we do this search in the next table to find some concrete tuples matching this condition? The beginning part is very simple, right? It's very similar. We start from the root, proceed down, and we match the records with the number 20 as an example. And if we can find some tuples whose age is no smaller than 20, and then we can do the sequential traversal. Because remember, for the leaf node, we have this pointer, right, pointing to the right hand side, the leaf node. In other words, if we can find some tuples, we matching our condition, we can just go right to find some more tuples whose value is larger than the current value, right? And we can do a sequential traversal, and we can access until this age is greater than 30, and we will return all the tuples we have reached in the traversal process. And we can provide you with an example within the B plus tree. And let's say we create a B plus tree, and we specify the D parameter to be 2. I always still remember this parameter, right? This D means all the key numbers in each node should be in the range from D to 2D. In this example, the number of keys in each node should be in the range from 2 to 4. Right? We have an exception, it is for the root. The root is the exception where now it contains only one single key inside it. And we create an index table with about the ages of the person. And the root will have one value, which is 80. It has 2 pointers, one pointing to the left hand side, one pointing to the right hand side. Inside it we have so many entries which are blank. It is a node, and it is also legal. And to the left hand side we have one children node. It's also the internal node. Inside it we have 2 keys. One is 20, one is 60. It's a node, right? Because the D value is in the range from 2 to 4. We have 2 keys. It's a node. And we have 3 pointers. The left pointer pointing to a children node, whose value is in the range from 10 to 20. And this pointer between 20 to 60 is also pointing to a children node. The key value in the children node is also in the range from 20 to 60. And this right pointer points to a children node. The value inside the children node is larger than 60. Remember, here we have 80, right? In other words, all the key values inside the children node should be from some values to 80, right? The maximum value will be 80. Similar for this one, right? The largest value will be in the range from 60 to 80, actually. It will be similar for this children node, right? On the right hand side, all the values inside the children value should be larger than 80, right? And we also have 3 keys for this children node: 100, 120, and 140. And left hand, and the left pointer pointing to a children node, the value range in this one should be between 80, right? Because this one is between 80, right? Because this one is larger than 80. In other words, this value in this children node should be from 80 to 100, and so forth. And the nodes in this level, they are all the different nodes, right? And inside it, we also have the keys. Now in this one, we have 3 keys, 10, 15, 18, and we also have pointers. The left pointer points to a tuple with such key value equals to 10, matching this key value. This one have a tuple with key value matching this 15. This one have one tuple matching 18. These are the concrete tuples stored in our database tables. So this part is the index table. And the bottom part is the concrete tuples stored in our database system. So they are very different, right? This is index table. These are tuples. And this one denotes the pointer pointing to some tuples we store in our database systems. And this one is a tuple with 18 as the key values. And this one, in these 2 entries are blank. However, for the right hand side is pointer, they're pointing to the next children node, the next leaf node, right? And for this one, we have the records matching 20, matching 30, 40, 50, etc., and so forth. So here, if we plan to do a search with the age value equals to 30, how can we do the search? We go from the root, right? We check this provided value 30 versus this key value. We find 30 is less than 80, right? Therefore, we have to go to the next branch, and we compare 30 with the key values. 30 is larger than 20, smaller than 60, right? Therefore, we have to go to this pointer and going down. And we'll compare the 30 versus all the key values inside the children node, right? 20, 30, 40, 50. And we find one tuple matching our value, right? 30. Therefore, we will access the pointer pointing to the concrete tuples matching our requirements or the values. And from this record, we can access the attribute, the name of a person, right? And we also return the name of the person as a result. So this is such a process for the equality queries. If we have some query now the condition is where the age is not smaller than 30, how can we do the search? We want to find some tuples whose age of a person is not smaller than 30, right? How can we find these tuples and also find the name of this person? The search process is very similar. We also use the 30 as a key value for comparison. Starting from the 80, from the root, we compare, go to the left, and go to the right hand side, and we can access the tuples, the value matching 30, right? We access this tuple, also give the name. Remember the condition we have is age is no smaller than 30. In other words, we can further go right hand side because we can ensure all the values on the right hand side are larger than 30, right? Because each node is sorted. And from this pointer, we further go to right hand side. We access this tuple as well, 40, this tuple as well, 50. And if we finish this node, remember we have a pointer pointing to the next leaf node, right? In other words, we don't have to access from root again and go to this node. We can directly going from this node to the right hand side to this node. We access the tuple with the age, which is 60, 65, 80, further go to this node, 85, 90, and further go to the right hand side. In other words, for the range queries, we can find the first entry matching our requirements, and we can further do the traversal to the right hand side to get all the tuples matching our requirements. Okay, so this is a search process in the B+tree. I hope you can follow me, right? And you can also try to do this search process by yourself by drawing down on paper. You can have a deeper understanding about search process in the B+tree. Okay, so this is about the example.